Last time I created this noise circuit that can play tones, and I've modified it here a bit. And with the help of my son, we built a little sort of a keyboard pad here. And all I did was take out the variable resistor, and I fussed with the values of this capacitor and this resistor a little bit. I don't remember exactly what they are at the moment, but we hooked this up here. And so all this really does is change the resistance in fixed increments. And I'll show a little montage of us building it. I didn't record any voiceover while I was doing it. We just messed with it for an afternoon, and I left the camera go for a while. So I have some video of building it. So I have this keyboard here, right? And the way it works is that the current goes from one side to the other as long as you're pushing a button down. Obviously, since I'm not pushing anything now, no sound is playing. And I wanted to kind of replicate the octave of a piano. I mean, I don't know much about this, but I know there's something like 12 buttons on a piano if you count the black keys. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 here that I'm calling my octave. And then here I have, which is kind of funny because octave means 8, but in any case, I don't know anything about music. So on this side, I have what I'm calling my octave selector. And all this really does is change like a bass resistance. So you have to push 2 buttons to play a tone. So for example, if I just push these, nothing happens. I have to hold on one of my octave buttons and I get tones, right? And if I push the next one, lower, and lower still. And so the way that works is that if I'm pushing this button here, the current's going to go through the blue wire, or whatever. The connection is through the blue wire, through the switch. And none of these resistors play a part in this. It just goes from here to here, through this resistor, and then into the network over here. If I push this button, then it causes the circuit to connect from here to here, at which point the current follows these yellow lines back down to red and returns. But if I don't push this button and I push the next button down, the current goes through this resistor. It can't go this way because I'm not pushing the button. So then if I'm pushing this one instead, it goes here and gets onto the yellow bus all the way down. So in that way, you can push one button at a time. And of course, the current will take the path of least resistance. Well, the first path it can find in this case, and it'll work. So if I hold down this, and the same exact logic applies here. I hope this sort of makes sense. These two parts of the switch and these two parts of the switch are connected. So if I'm not pushing this button, the current is going from blue across here, down this resistor, into this switch. And then if I am pressing this button, it goes into the switch and then crosses over to the other side of the switch and then can get on this yellow bus again. So the ones farthest down on the end here have the highest resistance because the current has to go through every single one of these to get there. And these are all, I think, 10K, so they all go up by 10K. And then that's why this one was 120K, because I wanted to jump a full step up. Okay, so this is my first octave, and if I push the last note on, I guess this would be the lowest note on my octave, like this. Oh, this switch, for some reason, it likes to bounce out. And I can't figure out. I've tried to bend these pins a bunch of different ways, and they just don't want to stick in there. Okay, so anyway, let's hold this lowest note here is the highest note of the next octave down, or close to it. It's close. Not quite exactly the same, but it's close. So then we go to the lowest note, and we go to the next octave, and the next octave's highest note. Very close to the same note. So in this way, you have like an entire... there's a bunch of possible notes, right? There's, 36 possible notes? 12 times 3? That sounds right. 36. Now, when I'd published the video previously with the SoundMaker that just had the knob on it, someone, and I can't remember where, if it was a YouTube comment or on Mastodon, pointed me to a thing called the Atari Punk Console. And they had said, I basically built the Atari Punk Console from first principles or something like that, which I thought was interesting. So I clicked on it. And as you can see here, I have it open. And the thing that struck me instantly is that it is remarkably simple. This half of the circuit is pretty much exactly what I already have. It's just a 555 in astable mode. And they put a variable resistor here connecting from 7 to ground, and mine has a 5, 6, 7. I hooked it up a little differently. I have a fixed resistor there, and then where I had the variable resistor is where they have this 1K at R1, and then I hooked mine off, now to my keyboard. But I think I'm just going to leave this like this and explore the second part of this circuit, which appears to be it's just another 555, but this one's in monostable mode. And I can't visualize in my head. I don't know what this is going to do to the sound. I know that right now, because what it's doing is it's taking the output from the first one, which I currently have going to my speaker, and it feeds that into the trigger of the second one. So that means that as the waves occur on this first timer, it's turning on a second timer here that fires once, I think. And then they have a variable resistor here to control how long those pulses that this ultimately generates are. But these pulses are the pulses that are fed from the output to the speaker. I'm not really clear on how that's going to change the sound. It's obviously going to have some kind of an impact. But in the interest of trying to make this sound maybe a little bit nicer, I'm curious to see what this sounds like. It mentions down here that it works, it's just an astable square wave oscillator driving a monostable oscillator that creates a single square pulse. I really don't understand, and I don't think it's explaining here because it doesn't make sense to me, why there's two and what that's going to do to the sound. But we're just going to have to try it because I don't have an oscilloscope. I can't look at the waves either to see, why are they different? I have no idea. We'll have to try to reason it out, I guess. Okay, before I can hook it up, I'm going to need to make some room, so I'll turn this off. I think I'll just set my keyboard up here and remove the capacitor, remove the speaker, because I won't be needing those. They're going to go directly into the next one over. So I think I can also remove, this was my resistor here, which the intent of that was to prevent the speaker from pulling too much current. I don't know really if this is correct. I don't think anyone commented on that actually, so maybe it was right. Okay, and I'll disconnect this too, and we'll do a different jumper in a minute here. Boop. Okay, I have my 555 in here, and I'm just going to look at the schematic and follow it and hook it up. I don't think I'm going to bother explaining while I hook it up. I'm just going to hook it up exactly like the schematic says. I'm ignoring the left-hand side of this schematic. So ignoring this side, I'm just going to, because this is nearly identical to what I already have. So I'm going to just leave what I've got. So all I'm focusing on is this side here. So I'll get that hooked up and we'll get back into it. Boop, 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 boop. Well, I just realized something. I have this variable resistor, and this is only, I think, up to 10K. And in this diagram, they're showing 470K. And I don't know if that means that it's set to 470, but that probably implies this is a much larger variable resistor. I need to look around and see if I have something bigger than a 10K, or else I might not get the range to see what this does. I suppose I could change things like the capacitor value, but I kind of want to hook it up as it is here first, just to get a sense of what's going on. Okay, I did find one that should go up to 500K, so I think that'll work. Unfortunately, it's the kind you have to use a little screwdriver in, but that's fine. We can manage. The only thing missing is my speaker, so I went from the output pin all the way over to here, so I'll hook that up to my speaker capacitor, and on the plus side, and then the speaker on the other side, and we'll see if it works. Now, I don't have my resistor in here that I went and did last time. I don't think it matters. I mean, it worked okay before. I just do wonder if that might cause too much current draw without it over to like the long term. I don't know. We'll see. All right, I think we're ready to turn it on. Okay, no smoke. That's probably good. Let's see what it sounds like. It's definitely really different. There's a change, but I can't quite put my finger on it. Let's try adjusting this. I'll go all the way to the left with it. Oh. Okay, that's more like how it was before. Maybe a slightly different. It has like a slightly different frequency to it. I'm sure it has something to do with. Well, we'll try and work it out in a minute here. I don't know if this microphone's going to pick this up. That's interesting. Okay, I don't think that made quite the difference I was expecting. I guess internally I was kind of thinking maybe it would create... I mean, there's obviously no reason for this. It's a square wave still. You know, I was thinking... A part of me was thinking maybe it would sound significantly better. I don't know. I'm not sure how to judge that. I mean, it sounds kind of cool. Is that better than without this part of the circuitry? I'm not really sure. It's different. I'm trying to reason about like how this even works, and or like what it's doing, right? Because I can't see the waves, so I don't really know exactly what it's doing. Okay, so we know that this side worked fine for the sounds and was creating a square wave just, you know, very quickly and causing the speaker to vibrate at a certain frequency and giving us our tone. So now that output is now going into this one, which is in monostable mode. At least this appears to be a monostable configuration, as my understanding. I never built one for the channel, but I mean, I read about them. And the monostable is basically like it gets triggered, and then after a moment, it returns back to its original state of being untriggered. So it's monostable. In other words, it has a single stable state that it sits in. Now, if I remember from this tutorial, which is what I used when I first built the left-hand side of my circuit, had a nice diagram here for that. So like you can see in monostable mode, pins 7 and 6 are connected together. There's only one resistor here between 7 and VCC. And if we look at this circuit, that's what we have here. We have one resistor between 7 and VCC. 7 and 6 are tied together. That's it, you know, pretty simple, right? And there's a capacitor hanging off of 6. So we go here, there's a capacitor hanging off of 6. So this is like, I guess what you would say, textbook monostable mode configuration in this circuit. So that must mean that every time this side of the wave goes high, this thing turns on, and then it stays on for a period of time based on the 555 timer formula, based on whatever value this is and whatever value this is. Okay, so the 555 timer calculator can of course support monostable mode as well. This one on this site, which is it's nice and easy to read, and it's clean. So I put in the values. We have the 0.1 capacitor here in this mode, and then we only have one resistor, and I just picked the middle here because this can go from 0 to 500K. So at 250K, we get a pulse duration of 27.5 milliseconds. So as we increase this, the duration gets longer, and as we decrease it, the duration gets shorter. So my understanding is that when we trigger this, additional pulses might be coming in on this trigger, but it's going to ignore them until that time expires and it gets back to the point where it can be triggered again. So what effect does that have on the sound? I don't know. You know, it's hard. I don't have a clear picture on this because this one was generating a sound all on its own. Why do we even need this second one? It clearly changes the sound in some fashion. But in what way? I guess what's kind of happening is that this frequency, the frequency that the second half is set to, means that whenever it's triggered, it's always going to blip for that amount. I feel like I'm missing something important here. Like, I don't know why you need this second one at all. It obviously changes the sound, but I was able to change the frequencies of the tones over here just fine. As this value gets higher, the timing gets slower and slower between the allowed pulses on this side. So that means that at a certain point, you know, you can be pulsing as fast as you want with this side. It's not going to matter. You're stuck. You know, it's going to effectively slow down the frequency, right? It's like a maximum. It's like a frequency limiter, I guess, in a way. Maybe that's a way to think about it, because right now at its max setting, this has the highest pulse length. And if you listen, I'm not sure there's any difference between the high and the low notes here anymore, because probably the pulsing out of here is so much faster than this side that, you know, this side's dominating, right? The pulse length determined by this calculation is always going to win because that's the one that drives the speaker. It almost takes the musicality out of it, right? The tones from my keyboard are just irrelevant when this is set to a really high value. And when I set to its lowest value, it's almost like this side isn't here because the pulse length is so short. So now we're seeing the frequency from this side makes it through because when this one triggers, the wave pulse is so short that, you know, the next pulse on this one that's generating it can occur at the same time, or it occurs at a point where it can trigger it again, right? It's ready to be triggered again. So it's almost like this isn't even here. So essentially, by turning this up, we're skipping pulses from this side. So depending on the value, it's like you might skip every fourth pulse from this side, and, you know, you make it a little bit higher, and now you're skipping every fifth pulse. And so you're losing more and more of the actual frequency that this side is feeding into it. So it's like getting flatter and flatter. I could kind of see where that might be useful on occasion to twiddle that and have a tone from this side that's going up and down, you know, a bunch of frequencies. And then, you know, here you can just sort of smoothly turn between them. That's a bit hard to do with my design here. Let me see if I can do. I'll just hold down this one. I really hope that sound is coming through because that's neat sounding. So that's more like a synthesizer, like you might you know, make electronic music with or something, I think. So probably my issue here is that I like the, you know, I have this keyboard thing here on purpose to make these separate stepped sounds, but that's not really what this is designed for. Really, there should be a pot here, and, you know, you could twist them and you'd get all kinds of crazy sounds. Okay. Oh, that's interesting. So I'm guessing that there's a big change here because we're hitting some kind of multiple of the frequency between this one and this one, causing it to to like skip more of the pulses depending on what this is set to. It creates almost like a stepped effect. All right. Well, that was fun. I like my piano keys as well, but that's a completely different way to apply it here. So probably this is not entirely compatible with this type of a circuit. This is for a totally different effect. What I'd like to do is figure out how to get maybe a more pleasing sound out of this, like maybe a sine wave or something. I'm not actually sure if there's a best sound or what to search for there, or how to even make those. It's hard to mess around with it because I'm not even sure where I would change values to get different shapes out of it, because this is still ultimately just a square wave. But it is very, very cool how it creates this interaction between these two sides here. All right, well, I think that's all for now. It was just fun to experiment with this and get a slightly different sound out of it. And of course, it was really fun to put this together. I think this is, I don't know, obviously I'm biased. I like this, partly because I did see a video thumbnail with something kind of like this, but I think the thing that I'm most proud of with this is that I saw a picture, didn't read anything about it, didn't watch any videos, and kind of reverse engineered it from memory and from screwing around. That's why I like this so much, I think. The sound on here, though, is really cool. I could imagine, with two larger, easier to turn knobs, this would be a lot of fun to mess with for sure. Unfortunately, I don't have another one like this, but that could be fixed. In any case, I guess that's all for now. So hopefully you enjoyed this. It was fun messing around with. Oh, and incidentally, I have a different microphone set up, and hopefully this sounds good. This is the first video I'm making with a new microphone setup, so I hope it still sounds okay. I guess we'll find out in editing. In any case, if you liked the video, thumbs up, subscribe if you haven't, and that's it for now. Bye. All right, I'm no DJ.